Hello class. So today we are talking about 5.1 and 5.2 still. And we're going to start off with something called the unit circle. The unit circle. So we were talking about angles last time. We didn't really talk about circles, but they're very well related. So the unit circle is just one of many circles on the XY axis, but it's like the best one. So it's the circle centered at 0, 0 with radius 1. So remember, the radius of a circle is how far it is from the middle to any point on the circle. So the middle of the unit circle is 0, 0. So the middle is not part of the circle, but it just tells you where the circle is. So don't think that the dot in the middle is a part of the circle, because it's not. What it's there for is to tell you, since the radius is 1, that from here to here should be distance 1. And that point is on the circle. So this guy, I'll draw in blue, that is on the circle because it's 1 away from the middle. So is this one up here, because it's 1 away from the middle in the up direction. So is this one here, because it's 1 away in the left direction, which I guess you would say it's -1 since it's going that way. And then same thing when you go down, you put a -1 to label that down there. So those 4 points are on the circle, and then you just sort of draw your best circle. It's not going to look good, probably. If you're like me and you can't draw well, then that's okay, you just do your best. There's no mistakes, just happy little accidents. Okay, so that's the unit circle with radius 1. So like, what are some points on the unit circle? Well, because the radius is 1, this point over here is 1, 0, because you go over 1, you don't go up. This one is 0, 1. This guy is -1, 0, and this guy is 0, -1. So those are 4 points that are on the unit circle, among many other points, of course, but these are 4 of them. These are all on the unit circle. But what about other points? So like, what about all the other points? Like something right there. Let me use the same color, blue. So, well, right now I don't know what that point is, but I do know it's some x, y coordinate. And what else can I say? Well, because the radius is 1, I know that the distance from that blue dot to this middle, how far is that? Well, the radius is 1, so that's got to be 1. And then, what about these green sides here? How far away are those? Well, this bottom green side, because the coordinate is x, y, that means I'm going over x and I'm going up y. And I'm making a right triangle because I'm just dropping that line straight down. So what's happening is, let me read, I have a triangle whose height is y and whose base is x and radius is 1. So the point is that whenever xy is on the unit circle, you get a little triangle like this. Now, how can I relate x and y together? Well, then you have to remember something called the Pythagorean theorem, which tells you what happens when you have a right triangle. It tells you that if you take one side and you square it, and you take another side and you square it, the two shorter sides, that's going to always equal, when you add them up, the hypotenuse squared. So in this situation, you get x squared plus y squared equals 1. So that's the relationship of any points on the unit circle. So no matter what point you look at, like if you look at this one, you look at this one, they're always going to have that xy relationship where x squared plus y squared is 1. You can test it with points that we already know, like this guy here. We know 0, 1. Well, if I plug it in, 0 squared plus negative 1 squared, does that equal 1? Yes, because you get 0 plus 1, which is 1, for example. Okay, so this is a very key relationship for points on the unit circle. XY coordinates are on the unit circle whenever this happens. Okay, so then how do we relate this to what we did last time with angles? Well, now we're going to look at the XY coordinates that correspond to very nice angles. Okay, so what this does right now, this hints at a relationship between triangles and circles. I guess that looks like an O, circles. And so let's look at that more by thinking about these triangles on the unit circle that come from very nice angles, okay? So let's do this first. So consider the angle theta equals pi over 4. So remember that that is 45 degrees. If you're still needing degrees to help you out to visualize things, that's okay. So that's 45 degrees. So what we're going to do is we are going to draw this 45-degree angle here. But then we're going to cut it off at length 1. And that must mean that this dot here is on the unit circle because the radius is 1. So in fact, I can just draw that unit circle there. And now we're going to ask, what is x comma y? What is this point on the unit circle when you go up by pi over 4? Okay, so what is the point x comma y? How can we figure it out? Well, this one's not so tricky, actually. We can figure it out by using the fact that x squared plus y squared equals 1 and some other little tricks. All right, so we're going to drop the line straight down to create a triangle. And then we'll zoom out over here and look at it some more. So all we know right now is that the xy point on the unit circle is, well, you go over x and you go up y, but we don't actually know what x and y are. But what we do know is that this angle is pi over 4. So remember, a triangle has to have 180 total degrees, aka pi over 2 radians total. Or sorry, pi radians total. So because this is already 90 plus another 45, the last missing angle up here has to be another 45 to get you to 180. So in fact, these two angles are exactly the same. And if you remember from a long time ago, maybe like in high school, if you have two angles that are the same, then this is called an isosceles triangle. And what that means is that the two corresponding side lengths are also the same. So this means that also x equals y, because the angles are the same. And what can I do with that? Well, what do I know about x and y? All I know is that x squared plus y squared equals 1 squared, which is 1. But now I know x equals y, so I can replace either one with the other one. So maybe I'll do x squared plus x squared. That equals 1 now. That gets me 2x squared equals 1. That gives me x squared equals 1/2. And then I square root both sides to get this, which people like to simplify. So you'll often see it this way instead, where I rationalize it by multiplying by root 2 over root 2 on the top and the bottom. And then root 2 times root 2 is 2. So then this is what people always say is the answer. But then that's the same as y. So that's also the same there. So what is the xy coordinate? It is, whoops, it is root 2 over 2 comma root 2 over 2. That is the xy coordinate corresponding to the angle pi over 4. Okay, so this is the relationship we study a lot in this section, which is given an angle, what's the point that the angle touches the unit circle at? That's what we've just figured out for this guy. So this is why pi over 4 is a nice angle. It's because I'm able to figure out this xy coordinate. If you just pick any old random angle, it's not going to work so nice. You're not going to be able to figure it out. There's only a couple places where you can figure it out easily, and that's what we're doing here. Okay, so the next one that is figure outable is 60 degrees, aka pi over 3. So that is one of the angles I said was a good angle last time. So still is. So again, the idea is you go up pi over 3 and you see when does that touch the unit circle, aka when is this length 1? Draw your best circle, maybe better than mine, hopefully. So what is this xy coordinate? This one is a little bit tougher to figure out, so you have to do a little trick, but it sort of works the same, which is you draw this triangle down, and then we're going to go and we're going to zoom out to try our best to figure out this triangle. So right now what we know is this is 60 degrees, aka pi over 3. This is still 90 degrees, aka pi over 2. So 60 plus 90, how much more do you need to get to 180? You need 30 more, because that gets you to 150. So that means that this guy up here, the missing one is 30, aka pi over 6. So this is the triangle we're dealing with, and we're trying to figure out what x and y are in this case. Whoops, y is the vertical one. So how are we going to do it this time? We have to play a little trick. So what we're going to do is we are going to use symmetry. We're going to draw the same triangle flipped over on the other side. So this is perfectly symmetrical if you're good at drawing, which means that this is length 1, that this is still 90 degrees, that this side is still x, and that all these angles are the same. And then we are going to notice something really cool, which is if you just zoom out to the entire triangle, you get an equilateral triangle. How do I know it's equilateral? How do I know all the sides are the same length? It's because this guy, what's pi over 6 plus pi over 6? AKA what's 30 plus 30? That's 60 degrees, AKA pi over 3. So these are all pi over 3s now. So they all have the same angle. That means it's equilateral. Well, since I know this is 1, I also know this is 1. And I also know this is 1. But I also know that this is x and x, AKA 2x. So what I know now is that 2x equals 1. So I've figured something out by drawing this little trick. So now my relationship x squared plus y squared equals 1. That's the relationship between the 2 points on the 2 coordinates on the unit circle. I can now also plug in this fact, so x equals 1/2. So I can stick 1/2 in there. And then I can solve for y, so that's 1/4 plus y squared equals 1. So y squared equals 3/4. Square root both sides, and you get that. So my x is 1/2 and my y is that. So my xy coordinate is 1/2 comma root 3 over 2. So the 60-degree angle, the pi over 3 angle, touches the unit circle at 1/2 comma root 3 over 2. But this actually lets us figure out the other one like instantaneously. So similarly, if you draw the pi over 6 angle, and you do the same exact trick, what's happening is you're getting that exact same triangle that we got before, but sort of rotated, because this guy is now pi over 3. So up here, this one was pi over 3, and this one was pi over 6. So it's the exact same triangle, just rotated about a little bit. And so if you do the exact same trick, you're going to get the same point, except now the x coordinate will be the y coordinate from before, so root 3 over 2 will come first. And the y coordinate from now will be the x coordinate from before, 1/2. So the point is that at pi over 6, the angle touches the unit circle at root 3 over 2 comma 1/2. Okay, so let me put all three on one picture just to summarize. I'll just do a little quarter circle here. So the point is that we have three very nice angles, pi over 6, pi over 4, and pi over 3. And the points that they touch the unit circle at are these points. We just figured them out. And a lot of times people get confused because they think like, oh God, I have to memorize all this. Well, you technically don't have to memorize because you could always try to refigure them out. But even if you do want to memorize, there's only a couple numbers here to remember. The middle one, the x and y have to be the same. So it's not like those could be anywhere else. And then this guy and this guy are really the same, but reversed, the x's and y's. And the lower angle, you go out further. So so this has to be the x coordinate because that's bigger than 1/2. So on the lower angle, you have to go out further than you go up. So that number has to be the x coordinate. Whereas in the other situation, you go up further. So it has to be the y coordinate. So there's various ways to remember. And then I guess we might as well write these points too, 1, 0. And then this one would be 0, 1. So what angles are those for? That's for the 0-degree angle. And then this one would be for pi over 2. So, and then what people do is they want to know about some other angles that look like these in the other quadrants. So remember, this is called quadrant 1. So what about the other ones? Okay, so now xy coordinates on the unit circle for some other angles that sort of look the same. Let's see, how do I want to do that? Sorry, let me think for 1 second. Okay. So let's do that. So the idea is, for example, if here's the unit circle, and this guy is pi over 4, then this point is root 2 over 2 comma root 2 over 2. Well, then on the other side over here, I'm going up to the same height and I'm going left instead of right to the same distance, then I should be able to figure out that point as well because it's symmetric. And I can, oops, I did too much, damn it. Try that again, okay. So what's the point that this angle will touch? Well, it's the same point, except I go left, so it's negative root 2 over 2. And then I go down, I still go up, so that's exactly the same. And then there's going to be one over here that's the same. But now I go left and I go down, so they're both going to be negative. And then over here, exactly the same, but I go right, and then I go down, so the y coordinate is negative, but the x coordinate is not. So what are these angles? So these are just other multiples of pi over 4. So what's happening is this guy is pi over 4, and then if I add another 45 degrees, I get up to here, and that you can think of as pi over 2, but it's actually 2 pi over 4. And then the next one is I add another pi over 4, and I get to 3 pi over 4. And then I add another one, and I get to 4 pi over 4, which is actually just pi, which we already knew. It should be pi. So to get to these other corresponding points that look sort of like the point for pi over 4, you just have to keep adding pi over 4s. So what's the next angle? What's this one? Well, it's 4 pi over 4 plus another is 5 pi over 4. And then another is here, 6 pi over 4. And then another, I'm running out of space here. That's going to be 7 pi over 4. And then the last one is 8 pi over 4, which takes you back to 0. So this is what we do in general. If you want to find out the corresponding angles for the same point. So let me draw a nicer picture here. So the fast way is something like this. So to draw all pi over 4s, what you do is you cut a pi into 4 pieces. You cut a half rotation into 4 pieces. So we cut the top into fourths. So how do I cut a top piece into fourths? I go 1, 2, 3, 4. That's 4 slices now. And then each of these angles will be 1 pi over 4 more from the next. So this first guy is pi over 4. The next one is going to be pi over 2. The next, because it's 2 pi over 4. So let me say it like that. The next would be 3 pi over 4. And the next would be 4 pi over 4 down here. And then to get the point on the unit circle corresponding to that angle, you just have to look at this guy and say, is it going left or down or up or right? And then it'll be exactly the same number-wise, except because you're going left in this situation, you put the negative on the x. And then you also cut the bottom into fourths to get the rest. 1, 2, 3, 4. And then it's the same picture that I drew over here. So let's do it with a different angle to see how it works for something we haven't already done. So let's do all pi over 3s. So that one's a bit trickier. So what I have to do now is I have to cut the top into thirds. So how do I cut the top half into thirds? Well, I gotta have 3 cuts then. 1, 2, so the middle line is not even a cut on the pi on the top half, because to cut something into thirds, I don't need this middle line. The middle line would cut it into half, which I don't need to do. When you're cutting into fourths, you do need to cut it into a half to make fourths, so that's why the y-axis is part of the cutting, but here it's not. So then what's going on is that this first angle is your pi over 3, and the next one is just another pi over 3, which makes it to be 2 pi over 3. And then your next one is 3 pi over 3. and so on like that. Then you cut the bottom into thirds the same way, 1, 2, 3, and you'll get 4 pi over 3, 5 pi over 3, and then back to the start, 6 pi over 3, which is 2 pi. Okay. So yeah, that's how you do that. And then we can do pi over 6s. Or sorry, let me do the points here too. So then you can ask, what's the point where the unit circle touches like 2 pi over 3? Well, because I know that this one is a half comma root 3 over 2 already, we figured that earlier, then I automatically know this one has the same numbers, except I'm going left, so the x1 is negative. And then down here, because I know it's the same angle, except in the other quadrant, I know automatically that it's the same point, except it's negative because it's going left, and it's negative because it's going down. Then over here, same numbers again, but I'm going right, so and down, so only the y number is negative. Okay, and then the sixths, so pi over 6s, to figure out where those are, I just have to cut it into 6s. So how do I cut something into sixths? I have to do 6 cuts. So 1, 2. Notice that that one is actually the same as pi over 3. And then here's the third cut. Now I do need to use the middle to cut something into sixths. You do need to cut it into halves, so the middle, it will be part of the cuts. 4, 5, and then 6. So this first guy is pi over 6. This next guy is 2 pi over 6, but that's actually pi over 3, and we already know about that one. What we're really looking for is the pi over 6s. So this is going to be, oops, I skipped one. So this next one is pi over 2, which is 3 pi over 6. And then 4 pi over 6, which is just another pi over 3 because they cancel. Oops, I didn't make this one low enough. Sorry, let me try that again. There we go. That's the one I'm looking for. And there's this one. Okay, so 4 pi over 6. And now we get the one we want, which is 5 pi over 6. So the point on the unit circle, because I already know this one, I automatically know this one is the same except with x's. Okay, so then this is 6 pi over 6. And then keep going. On the bottom, you make 6 cuts as well. 1, 2, 3, 4, 5, and 6. So that'll be 7 pi's over 6, 8 pi's over 6, 9 pi's over 6, 10, 11 pi's over 6, and then 12 pi over 6 gets you back to 2 pi, which is 1 full rotation. And then the points we care about are these ones, the pi over 6s that don't reduce. So this one and this one. And again, the coordinates on the unit circle are the same, except negative sometimes. Okay, so in general, what we do is we care about all the pi over 3s, pi over 4s, and pi over 6s. And we care about the points that touch the unit circle for those angles. That's the lesson here. And these are all the points that we care about. Okay, this red, this green, and this blue. And we also care about the corners, which we said at the beginning, like 0, 1, 1, 0, negative 1, 0, and 0, negative 1. All right. But what we do now is we introduce a new notation to help us compile this information. So these x and y coordinates, these points, are so important. We invent a new notation. Okay, so here's what we do. Given an angle, theta, with corresponding point on the unit circle, So we're in a situation like this. Given a theta and a point x comma y on the unit circle, we create a notation that relates them together. We define something called sine of the angle to be the y value that you get on the unit circle. So this is how you write it, and how you say it is sine of theta. Then there's also the x. So what do we call the x point? We call that cosine of theta, or we write it like that. Okay, so all that stuff we just did, we sort of reduce it down to these two things that sort of start to make it seem more complicated, but it's actually just to save a lot of time when writing these things down. Okay, so let's use this notation. Let's practice with it. So what is sine of pi over 4? So what is that? Well, what that means to do is look at pi over 4, the angle. What is the xy coordinate that touches the unit circle there? Well, we already figured out that it was root 2 over 2 comma root 2 over 2. So what is sine of that angle? It's just the y value. So there it is. That's it. What's sine of pi over 6? Well, we already did that one too. So if this is pi over 6, we already know the point was root 3 over 2 comma a half. So what is sine of pi over 6? It's the y value for that point corresponding to the angle pi over 6, so it's 1/2. And then we can do more complicated ones. So what is sine of, let's do 2 pi over 3. Well, to figure that one out, what we do is we first do our pi over 3 thing that we just did. So we say, okay, I'm going to cut this into thirds. 1, 2, 3. That way I can figure out exactly where 2 pi over 3 is. So here's pi over 3. So then this must be the next one, 2 pi over 3. So I know that this point is 1/2 comma root 3 over 2. So then I know this point is negative 1/2 comma root 3 over 2. So then sine of 2 pi over 3 is just the y value. So the y value is this guy. So that's the answer. So all we're doing is rephrasing all those points and angle relationships into a nicer, smaller notation that helps us say things much more quickly. Okay, so like what about some cosines? So example, like what's cosine of, I don't know, let's do 7 pi over 6. So now what I'm looking at is I'm looking at a pi over 6. So basically I already know that because it's a pi over 6, I'm looking at this angle here, and I'm looking at this point here, and I'm looking at the x value because it's cosine, but I'm doing it for 7 pi over 6, not pi over 6, so I got to find where that is. So that's 1 pi over 6. Now I just cut it into 6. That's 2 pi over 6. Up here is 3 pi over 6, 4, 5, 6. So I could just very quickly count to 7. So I know that this is 7 pi over 6 without labeling everything. Then I immediately know that the point is the same point, except I'm going left and I'm going down. So this is going to be the x coordinate there. So it's negative 3 over 2. Not so bad, I hope. Well, let's do another cosine. Cosine of, let's do 7 pi over 4. So what is that? Again, it's an x value, and it's the x value for a pi over 4 angle So I first think about pi over 4, and I already know that the point for that guy is root 2 over 2 comma root 2 over 2. Now I just got to find where 7 pi over 4 is. So that's 1. I cut it into fourths. So that's 1, that's 2 there, 3 there, and 4 there, 5 there, 6 there, 7 is right here. So that guy is 7 pi over 4. So it's the exact same point, except I'm going down, so the y is negative. But I'm looking at cosine, so I'm looking at the x coordinate for my answer. So there it is, root 2 over 2. Okay, so basically what people do is like in high school, for some reason, they have you like memorize the whole unit circle. But I think the whole point is that you only really need to memorize the first 3. Well, you should just know these ones. So you should know, well, let me draw it better actually, sorry. So you should know this guy really well, the first quadrant. So this is like 1, 0, 0, 1, and then you should know the pi over 4, pi over 3, pi over 6 stuff. So you should know these points, like I said earlier, and then use them to get the others. That's the best way to do it, so you don't have to memorize the whole circle. You only have to memorize a couple of them. So I'll remind you what they are here. So that's for pi over 6, pi over 4, pi over 3. So then if you want to answer questions like sine of pi of, I don't know, 5 pi over 4 or something, then the idea is that you're just looking at the y coordinate of pi over 4, but you're thinking about it somewhere else. So that's 1 pi over 4. Then this would be 2, 3, 4, 5. So you just count to 5 by cutting, after cutting things into fourths. So you make sure you cut into fourths. 1, 2, 3, 4. This would be 5. So then you're just looking at the same point. But now, since it's going down, it's negative. So that's how you do any pi over 4, pi over 3, pi over 6. But don't forget the simpler ones. So like what would be cosine of pi over 2? That one's actually one of the ones we have done. I just haven't explicitly done it yet. Pi over 2, that is the 90-degree angle. That's this guy here. So what's the point there? It's 0, 1. Because you just go up 1. So the x value for cosine is 0. And then what would like sine of pi over 2 be? That would be 1, because it would just be the y value. So pi over 2, pi over 3, this is what you should be able to do. Be able to calculate sine of an angle, cosine of an angle for pi over 2s, pi over 3s, pi over 4s, pi over 6s, and also just pi's. So what would cosine of pi be? So that's the last one. Pi is just the half rotation all the way around. So that's pi. So what's the point on the unit circle there? It is, you go left 1 and you don't go down or up, so 0. So cosine is the x coordinate, which would be -1, and sine is the y coordinate, which would be 0. Okay, so that's about it for today. You just have to do lots of practice calculating these things and understanding the unit circle as best you can. Okay, see you next time.